Welcome to the CircuitPython Show. I'm your host, Paul Cutler. This episode I'm joined by Alec Delaney. Alec is sponsored by Adafruit to work as a part-time developer on the CircuitPython project. He works on the Python libraries as well as the continuous integration across the organization. He's also a maker working with CircuitPython to create robot friends and currently works full-time as a mechanical engineer for a medical device company. This episode is brought to you by PCBWay. With over a decade of experience, PCBWay is one of the most experienced manufacturers in PCB prototyping and design. Whether you're an engineer, student, or hobbyist, PCBWay offers a simple and fast prototyping service, and it's cost-effective at only $5 for 10 PCBs. And check out PCBWay.com/project, where PCBWay helps makers and hobbyists collaborate on their designs and projects. Make your design a reality and check out PCBWay.com for all your PCB needs. And they also now offer CNC machining and 3D printing services. Visit PCBWay.com for more information. Thanks to PCBWay for their sponsorship. Alec, welcome to the show.
Thanks for having me.
I'm glad you're here. Tell me how you got started with computers and electronics.
Yeah, the first memory I have really of programming on a computer actually was, I think, back in grade school. It was with JavaScript. So I started off. I know a lot of people start off with like C or whatnot, but I started off with a pretty dynamically typed language. So that's how I got my start. And then I went to school for engineering, but I actually went for mechanical. But one of the courses we had to take was a kind of like a programming course where we had MATLAB, which is a language used pretty much a lot by mechanical engineers and electrical. And then the other one was actually C++. So that was kind of my second language. But then being in a field sort of next to hardware and data collection and therefore data science, Python came up pretty quickly thereafter. And so I found Python, and then, being in hardware, knowing Python, it was only a matter of time before I stumbled upon CircuitPython. And I fell in love immediately, just to be able to have an idea and know Python and get started on a microcontroller, to remove that barrier of knowing how to compile or set up a tool chain. It was magic to me.
You're sponsored by Adafruit to work on continuous integration using GitHub Actions for a number of the CircuitPython repositories. For those that might not know, what is continuous integration, or CI?
Yeah, continuous integration or continuous development is the process of basically removing the manual steps from parts of the code cycle. So, of course, there's development and there's writing code, but there's all the other parts like testing and shipping that need to happen to kind of create good code and best practices. And so what CI does, continuous integration, is the process of constantly doing those, right? So instead of, asking people like, hey, do you mind testing that code? Or, hey, do you mind zipping it up and uploading it? It does it automatically, basically. And so it's that process, just really, those are just some parts of it. But the CI for the CircuitPython project and Adafruit uses in general is pretty varied in what it does. But it all does that basically. It all automates these sometimes critical processes behind the scenes, so that everything just kind of works seamlessly.
So tell me about some of those things that are behind the scenes that the average user doesn't see, that makes all of this happen to bring CircuitPython to that user.
Yeah, so the CI that Adafruit uses for CircuitPython and really the whole CircuitPython ecosystem, some of them are kind of where you might expect in that traditional side of things, right? So, for example, one important job the CI does is for actually taking all of the library code and kind of bundling it, quite literally, for the CircuitPython bundle, and creating that bundle and uploading it to various places. For example, CircuitPython.org. It handles uploading it to there. It also handles creating GitHub releases. So All of likewise, it helps put it on PyPI. So it does all of these, more traditional things that you would expect a CI to do. Again, there's a whole bunch of infrastructure for testing code. All the code comes whenever you create a library or submit a change to a library. All the formatters, a linter runs, all of these very traditional CI things. But what's really cool is that we actually use the CI for some other things that are, and I would say are pretty important, even if they aren't the most traditional use. For example, the weekly meeting that's held every Monday, um, show notes, or not the show notes, but the meeting notes for that are actually generated by the GitHub Actions CI, which is really cool because a lot of the stats we're reading, how many pull requests, how many milestones, who are our new contributors, right? That information is GitHub information. So we're able to take that and run it through the CI and get that, almost natively if you think about it. And then create this document and upload it to AWS. And so that whole process is completely automated. It's actually automated daily. So at any point you could see that information. We only read it once a week. But yeah, I think that part of the cool thing is that we use CI pretty regularly and pretty widespread across the whole project.
How does the continuous integration make it easy for developers and or the users?
Yeah, that's a great question. I would definitely say that, for sure, it's probably felt most palpably by developers or even just contributors in general. Especially with those traditional things. One of the most important things as a developer when you're writing code is that, when you submit it for a pull request, other people are going to be looking at it. So you not only want to make sure that it's good code, but that other people can follow along. And so, of course, that means things like commenting and whatnot. But part of that, for example, is readability. So part of what the CI's job does across all the libraries is formatting, right? So we use Black. It is, if I remember correctly, the tagline is the unrelenting formatter. And so it pretty much standardizes what code will look like. If I ran Black on the same code as you, we should get the same thing. So what's great about that is that, when I write code and other people are going to look at it, I can focus on really what it should be doing, right? I focus on, is it doing what it needs to do? And then kind of throughout the process, or even at the end as well, I can have all these automated tools run and say, okay, I'm going to move this over here. It seems more readable. Or I can have the linter say, oh, hey, I noticed you aren't using this variable. We should remove it. And so I can focus on writing the code, and anyone who's contributing can do the same. I would say for the users, it's definitely the more not fringe, but the other uses of that. When we talk about how people load code onto the Feather M4 Express, which can hold, I think it still can, all of the libraries. And so that's where the bundle comes in. That bundle is created by the CI. And so from the user's perspective, it's as easy as going to circuitpython.org and just picking up this zip file. But behind the scenes, there's the infrastructure to make the zip file, and before that, there's infrastructure for making sure if someone updates one of the repositories that gets put in the bundle, and you can go up the chain for a long ways from there. But in the same way that CircuitPython makes editing code really easy. The whole project and Adafruit in general uses CI to just make the whole development and user perspective a lot easier.
And all of this is done using GitHub Actions?
Yeah, for the CircuitPython project and Blink and related things, I know that GitHub Actions is used. I think before that they used Travis, which
That was a popular CI back in the day.
Yeah, I think I think even the Arduino libraries still use it. But yeah, everything is pretty much all GitHub Actions, and that's its own ecosystem of cool tools and whatnot. One of the projects that's on my plate now is a lot of that has to be updated. So I am actively taking a look at that all over again. So
One of the other projects you're working on is moving packaging to use the pyproject.toml files. What are some of the challenges in moving to that system?
So one of the biggest challenges of that is, it is honestly just how to do it. Um, the task is just one of those things where the task is really simple. A lot of the information is already there in what was setup.py. So the previous file that had all of the information for PyPI, and if you installed locally, how to do that. Um, but moving that to a new file format is tricky because you can't just blanket copy things. So you can't just copy paste things, of course, but you also can't just use. It's hard to use a template because some of that information is specific to those files. So some repositories, for example, have keywords so that if you're on PyPI, you can search for them. So those are specific to each file. So it's a blend. The real challenge there was a blend of how do you use templates, and there are some tools like Git can. I think it's called, if I remember correctly, format patch. So you can make a commit in one Git repository, and Git can kind of try to apply it to other ones, and that's actually something Adabot does, which is really the mastermind developer tool for helping with some of these things. But it's hard to do that here because some of the things, you can't do that with keywords, for example. So it took a lot of manual tooling behind the scenes, along with the CI, to kind of create a hybrid solution that could, template these files and and upload them. And then of course there's the whole tooling for getting it, checking it and making sure that everything went correctly. One of the classic failures is, and I still have to remind myself that they aren't the same, is there Python in the packaging world, there's modules, which are these like single files, and then packages, which are a folder of files. And from a user's perspective, they're entirely the same. But when you're writing these files, it's really important to tell the file which it is, and if you get it wrong, it may not be clear, and it sometimes even slip through the CI. So how do you check things that sometimes can silently fail? So it was all around just a conglomerate or a conglomeration of different problems with unique solutions. So it was definitely one of my favorite little tidbit challenges so far.
What are some of the benefits by moving to a pyproject.toml?
So pyproject.toml is a configuration file for pip. So setup.py is an executable file like any other Python file. And the way it works is you import setup tools and you give this setup function all the information you need, and then it builds. The issue with that is you already need setup tools to use it. And so it kind of creates this chicken and egg problem where you need setup tools to call that setup function, which in turn has a setting in it that you can tell it what dependencies you need. But in order to do that, you already need it. And so that was the major problem that moving away from setup.py to pyproject.toml solves. That wasn't necessarily an issue for us. A lot of builds come with setup.tools. It might even be default with Python, which is how it gained such a foothold. But there are other build packages or build tools, like Flit is another one. And they use pyproject.toml for that same reason, where they specify what they need to build, and then pip will go install that and it will do that in a virtual environment and then build the package. And it'll build wheels, it'll build a source distribution, it'll do all of that. That isn't to say that setup.py doesn't have a place anymore. I know one of the major places that I see it a lot still is with the use of Python. So Python is a language that you can write, and it basically is kind of Python-like, and it gets basically compiled down to C code, like any other Python C extension, and then that gets compiled like any other Python C extension. But in order to do that, you need to do a couple things in the setup.py file. So moving things to pyproject.toml at least gives them the chance to say, hey, like these are the build dependencies we need. And in that, you can even specify Python. So that's definitely the predominant reason. And then it also gives us the ability to, if in the future we want to move away from setup tools to something like Flit or Poetry that both use pyproject.toml, it gives us a better way to do that now that we already have that. And to be fair, I know that Blinka, for example, still needs to use setup.py. So again, as an executable file, it's able to do runtime dependencies. So one thing that Blinka does when you install it, it checks for specific libraries that are only available on the Raspberry Pi. So what it's able to do is, as you're installing, it can say, hey, are you a Raspberry Pi? Great, here's some libraries I'm going to throw in as a dependency. And if not, then it doesn't do that. So even on our own projects, there's still a place for setup.py.
All right, tell me about the CircuitPythonukiah.
Yeah, so I had for a while been wanting to make a project that I could share with people. So a lot of my robot friends that I had made, when I'm not working on the CI, I love working with the CircuitPython boards themselves. I wanted to make a project that wasn't hyper-specific like some of my other ones had been, because I wanted to share it. And one of the things I've really enjoyed about being, working with Adafruit and just working with open source in general, and some of your other guests have mentioned it, is how great it is and how much you can learn from people in the community. And there's a lot of great makers that do open source hardware, and it was really inspiring to me. And so I wanted to do something that wasn't hyper specific, and I wanted to do something that I could share. And so when I was thinking of things, I think one day I had come home, much around this time when, up in the Northeast, it gets dark so early around the holidays. And I was thinking, oh man, like I'm going to be late to light candles for my Hanukkah, or, you may say menorah. And it kind of hit me that I was like, I could probably automate this. Like I could probably come home and it could be lit. And so it kind of like what started off as this neat idea of having that happen turned into this project. So the CircuitPythonukiah is exactly that. So it's a custom PCB, which was fun. It was my first PCB that I've made. And what it does is it's got LEDs on it, and it runs on a QT-Py S2. And it's got the LEDs. It's got a piezo electric buzzer on it. And what you do is you plug it in. The QT-Py S2 connects to the Wi-Fi, and it looks up the date. It looks up when Hanukkah is, and then it says, either, hey, it's Hanukkah, and it lights up the correct candles and plays a little tune, or it will wait to do that. And what's really exciting is it's been the first project that I've done in open source that I went and got open source hardware certified. So
good for you.
Thank you. So I went and got it, and now I just reordered the boards with its certification mark on it, and I'm excited to hopefully, if the holidays slow down a little bit in how fast they're coming, I'll try to get those out to people before Hanukkah starts.
What a great project. My last question for you. You're about to start a new project. Which board do you reach for?
Yeah, I'm definitely biased after the CircuitPythonukiah project. I would definitely have to give two answers. I think that any of the RP 2040 boards, especially with chip shortages and whatnot, how available those have been and how cheap they are, it makes it just a fantastic chip to work with. Knowing that I can grab any one of the CircuitPython boards that has the RP 2040 and start hacking away and not have to worry about too much is great. And how on top of things they are. Shout out to Jepler, who with the PyCal, the Pico W, how great that is. Any chip now, it has Wi-Fi built in, right? So now you can use the RP 2040 and great, you have Wi-Fi included. But I also do. There's a special place in my heart, not just from this project, but more from my mechanical side, where when I'm thinking about how I'm gonna make things and make things small, especially the QtPy format, and specifically, I've really enjoyed the S2. Just knowing that if I'm doing something small, or I want to, there's a lot of constraints, and I only need a few inputs and outputs anyways. Just knowing that I can make something and add that to the board really quickly, and have a lot of flexibility on just one tiny little format is just a joy.
I'm with you. My current projects are using the ESP32S2 as well, and it's just a great chip to work with. And having Wi-Fi just changes the entire game.
Absolutely. I figure if the CircuitPythonukiah, perchance doesn't happen this year, I've already made the order, and I already have 15 QtPys here. And if I have to use them for other things, then oh well, so be it.
I'm sure you'll find a use for them. Alec, thanks so much for being on the show.
Thank you so much.
Thanks to Alec for being on the show. That's a wrap for Season 2. Thank you to everyone who has listened, and the show will be back in early 2023. Until then, stay positive.